Okay, in this video I'm going to continue on with exercise 6b of the book Fundamental Applied Mathematics. We're on page number 162 and the question is 7. It reads, water is pumped from the bottom of a 30-metre well to the top at a rate of 1 metre cubed per minute. Find the work done every minute, the power output of the pump, and also note that 1 metre cubed of water has a mass of 1,000 kilograms. And yes, there is an airplane flying overhead there, making loads of noise. Just wait one moment. Alright, okay, so the first thing to note is that mass is equal to density times volume. We use the Greek letter rho for density, but in this case we're actually given that the mass is equal to 1,000 kilograms. Alright, so the first thing we need to do is find the force on each kilogram of water. Okay, so we know that F is equal to ma, or the sum of the forces is equal to the mass times the acceleration. So the mass is 1,000 kilograms. The acceleration is negative 9.81 meters per second squared, which is gravity. So the sum of the force vectors really is, what's that now, 9,810 newtons. It happens to be going in a negative j-hat direction. Alright? So that was pretty straightforward. The next thing we need to do is to find the work done. So I'm just going to note that F is equal to 9,810 in a negative j-hat direction. Now we know, of course, that work can be negative, it can be positive, and it can be equal to 0 depending on the direction and so on. So we know that work done is equal to the force times the displacement. So in this case it's equal to negative 9,810 j-hat times 30 j-hat, giving an answer of 9,810 multiplied by 30 of 2.943 times 10 to the 10 to the 5 joules, or 294,300. So that's the work done, but it is negative because it's obviously going in a negative j direction. So that's the work done. Next we need to find the power output. So you know PAV is equal to the work done over the time. So we need to, it's work done per minute. So if it's 2.943 times 10 to the 5 joules per minute, or the magnitude of it, excuse me, it's done that every 60 seconds. So divide our answer by 60 and we get an answer of the power average is equal to 4905 watts. And finally, no, that is it, that's it. Okay, so what I'm going to do now is check that answer at the back of the book. Just bear with me there a moment. So we're on 6b, question 7, and 4.9 kilowatts is correct, and so is kilojoules. Both of those are correct. So thanks for watching. Please pass it on to your friends and subscribe to my channel.